Okay, today's lesson is on congruent triangles. And our goals today are we're going to prove that triangles are congruent using the definition of congruence. And we're also going to use the properties of congruence to help us solve some simple problems. So the basic definition of congruence for a geometric figure is that the two figures have to be the same size and the same shape. To show this, we have to look at something called corresponding sides. So corresponding sides and corresponding angles. And the word corresponding you can think of as meaning to match. Okay, so each side in one figure is going to match or correspond to another side in the other figure. And it's a one-to-one correspondence. Okay, so here we have a chart with two pairs of congruent figures, and we're going to focus on the triangles. Everything we're talking about is also true for polygons, in this case a pair of rectangles, but triangles is our focus. So now if I look at these two congruent triangles, notice that there are 6 pieces to a triangle. You have 3 angles and 3 sides. And to show that by the definition that we have congruent figures, we have to show that all 6 parts match up and are congruent. And so the angles are the most simple parts, but notice that angle A has 1 tick mark, so in the other figure, angle D has 1 tick mark, so A is congruent to D, and so forth. B matches E, so B is E, and C matches F, so C is congruent to F. Now the only thing I will say about that is that we want to keep the order to be the same. So if I started at the figure ABC, I'm going to end at the figure with the EDF. So don't go backwards. The next one is the sides, and that's a little more tricky because notice if I talk about side AB, that's going from the angle that has 1 marking to the angle that has 2. I want to continue that pattern when I talk about the congruent side or the matching side. So although segment AB can be named as AB with the line over it and BA with the line over it. They're considered equivalent. When we're talking about congruence, we don't want to consider them as being equivalent. So here I'm talking about segment AB. So I'm starting at this angle with 1 marking to the angle with 2. So when I go over here to the second figure, I want to go from the angle with 1 marking to the angle with 2. So I'm going to say AB is congruent to DE. And so that's what we have here. It's very easy to forget that and go in the other direction, but when we're talking about congruent statements, we do not want to do that. We want to continue the same pattern. So from A to B is going to match D to E. When we talk about BC, that's going from two markings to 3 markings. So side BC, I want to say 2 to 3, I want to say EF. So BC is congruent to EF. And then the last side is AC, and so that goes from 1 to 3. So when I talk about AC, I want to match it with DF, which goes from 1 to 3. Okay, so here's a simple task. They want us to name the corresponding parts of 2 triangles that they tell us are congruent. So in this picture, we can see that we have a piece of machinery. It's actually part of a spacecraft, but we really don't even need the picture because over on the text it says triangle RST is congruent to triangle XYZ, and they want us to identify the corresponding and congruent parts. Well, the easiest part is the angles, and because we are careful about how we name the order when we're talking about congruence, I know that angle R, the first letter is going to match the first letter of the second part. So angle R is congruent to angle X, and so forth. The middle one, angle S, is going to be congruent to the middle one, angle Y, and the last one, angle T, is going to be congruent to angle Z. And it's pretty similar for the sides. The only thing to remember in sides is that, our notation here goes in a linear fashion, but in an actual triangle, we're going around the figure as we name the sides. So at the very last side, we have to kind of loop from the last letter to the first. So we can say, first of all, RS, side RS. Remember, you need the line because we're not talking about distance, we're talking about the actual side. So side RS is congruent to side XY, and side ST is going to be congruent to side YZ. But at the very end, we have to kind of loop back. So we have to go from TR. So we're going to go side TR is congruent to side ZX. And so those are our 6 congruent parts. Here we have a picture with 2 triangles, and they are congruent. And one thing I want you to notice in this picture is that oftentimes in these problems you have triangles that share a side. And so we know that this FH here, it's in both parts, it's considered congruent to itself, which seems kind of strange, but also common sense, doesn't it? So it's the same length as itself. So in this particular problem, there's 2 things we want to find. We want to find X, and we also want to find the angle GFH. And we can do that by using the idea of congruence. So if we match up these angles, we can see E matches G. So I know that this is 21.6 for G. I also can see that this algebraic expression 6x minus 12 is going to be a 90-degree angle. So I'm going to say 6x minus 12 equals 90, and we can solve that. So 6x is going to be 102. Actually, fix that by writing a little bit. So 6x is 102. And I can divide by 6, and that's going to be 17. So x is 17. That's done. Then the last bit is to find that other angle. And so I know that I have in this triangle over here, this one on the right, triangle EFH, not EFH, triangle GFH, that I have 2 angles that I know. I know the 90-degree angle, and I know that the other one is 21.6. So if we add those together, we get 111.6 degrees. I know that I have to have 180 in an entire triangle, so if I subtract out that 111.6, I'm going to have the missing angle. So I'm going to do it in pieces because I'm doing it in my head. So I'm going to subtract 100, that'll give me 80, and then I'm going to subtract 10, that'll give me 70. I'll subtract 1, that gives me 69, and then the last bit, I'm going to subtract the 0.6, and that's going to give me 68.4. So GFH, angle GFH is 68.4 degrees. Okay, so here we have a proof that they're asking us to do. They want us to show that these 2 triangles, triangle RPQ and triangle RMN, are congruent. And the way we're going to do that is we're going to show that all 6 pieces of the triangle make congruent pairs. So we have 3 pairs of congruent angles, 3 pairs of congruent sides. So let's start with, we're going to do it on 2 slides. Let's start with just thinking about the angles. So what do I know about this picture? Well, one thing I can see is that angle P and angle M are right angles. So right angles are congruent because they're all 90 degrees. So that's one piece of information. I can also see from this picture that this angle at the pair that happens at R, those are vertical angles. Oftentimes when you have triangles connected in this fashion, you're going to use vertical angles somewhere. And so we know vertical angles are congruent. So far we know that 2 pairs of angles are congruent. And the theorem we learned the other day, called the third angle theorem, says that if I have 2 pairs, the red pair and the blue pair, that are congruent, then this last pair, the green pair, also has to be congruent. So those are our congruent statements. So let's write it out here. So the first thing we're going to say is the red pair. We're going to say angle P is congruent to angle M. Why? Because right angles, they're all 90 degrees. Right angles are congruent. That's my reason. Then we're going to look at the second pair of angles. Now, to name the vertical angles, we're going to have to use 3 letters, 3 vertices. So we have to be careful how we name it so that they're in the right order. I'm going to start with the right angle. So I'm going to say PRQ. So the right angle, then R, and then Q is going to be congruent. So I'm going to start with the right angle, MRN. Why is that true? Because vertical angles are congruent. Then that last statement is going to be true. Just angle Q is congruent to angle N. Why? Because of that theorem we had, the third angle theorem. And so therefore what we've shown so far is that all corresponding angles are congruent. Okay? So now if we can do the same thing for the sides, we're going to know those triangles are congruent. Okay, so in this part we're going to show that the sides of the triangles are congruent. And once we do that, combined with the fact that the angles are congruent, we can say that these are congruent triangles. So the first thing we're going to notice is that they gave us quite a bit of information here. We can already see that we have QP is going to be congruent to MN because they told us that in the picture. We can also see that QR is congruent to NR, and that was also given to us in the picture. What we don't know is why we would say that PR is the same as MR. But if we go back to the given information, we can see that it says R is the midpoint of PM. Well, if R is the midpoint, then we know that the distance PR is the same as the distance MR. And if that's true, then those segments are indeed congruent. So let's go ahead and write this up. So I'm going to write all the given information together. So we know R is the midpoint of PM. We're going to use that. And also the fact that PQ, they already told us PQ is congruent to MN. And QR is congruent to NR. That was given to us. So all we need to do is take the midpoint information and explain why those the PR has to be congruent to MR. So the fact that R is the midpoint of PM, we can conclude that PR, the distance, is equal to MR. That's the definition of a midpoint. That's what midpoint means. And if the distances are the same, then I know that these segments are congruent, because that's what congruent segments are. They're segments that have the same length. So this is definition of congruence. And now we've shown everything we need. We have the fact that PQ is congruent to MN, PR is congruent to MR. Oops, not that one. Let's undo that. PR is congruent to MR, and QR is congruent to NR. Those are the 3 things we needed to show. So based on this information and the information on the previous slide where we showed the angles are congruent, we're going to say triangle RPQ is congruent to triangle RMN. And the reason is by definition of congruent triangles.